A linear function is any equation of the form f of x is equal to mx plus b, or you could simply say y equals mx plus b. M is called our slope, which has this formula, and b represents the y value where the graph goes over the y-axis, or the y-intercept. Let's explore these in the function f of x equals 2x minus 5. We'll graph this, look at its slope, and talk about its y-intercept. So to graph this equation, we just need 2 points. That means we can choose a couple of x values and solve for the y values. So I'm going to choose x equals 0. If I put that into my function, I get 2 times 0 minus 5. And if I simplify that, f of 0 gives me negative 5. And that's a point, the point 0, comma, negative 5. So I'll put that right here. I need one other value, so I don't know, maybe I'll use 3. If I choose x equals 3, I'm asking what is the y value for this x value. So that is f of 3 is equal to 2 times 3 minus 5. That's 6 minus 5, or f of 3 is equal to 1. That is the point 3, comma 1. So that's located right here. My graph is just the equation that goes through those 2 points. So I've drawn like a basic sketch of a line going through the points that we found. But now I'd like to talk about is, for this given line, it definitely falls into this form. In fact, you can copy down a couple of things from it. One of those being, well, the value m is going to be 2. That is the number that appears in front of the x. And the value for b, that's equal to negative 5. The negative 5 is what shows up right here. This is the y-intercept. Technically, it's the point 0, negative 5. The number at the end of the function is always going to tell you the y value where the graph crosses the y-axis, because if you put I chose 0 into the function, it cancels the first part and just leaves you with this number at the end. So really, if I wanted to graph this, I could just look at this number and put a point here, and then just use the slope to get a second point. So now let's talk about the slope of this line. Slope is a number that tells you if your line is increasing or decreasing, and by how much. Like for example, this line is increasing, and that has something to do with the number 2. A very basic definition of slope is rise over the run. So I could have more precisely said the slope of this line isn't just 2, but it's 2 over 1. The way this works is, if you look at your graph, if you go over 1 and up 2, you should end on the line again. So my sketch was a little sloppy, but I can put this point right here. So if I go over 1 and up 2, I end up on the line. If I go over 1 and up 2, over 1 and up 2, I should always end up back on the line. And that is coming from this number here. I want to now use this formula and a couple of points off of this graph to verify it for slope. A more precise way to define slope is the change in the y values over the change in the x values for 2 given points on your graph. So what I'll do is I'm going to take this point and this point, call them x1, y1, x2, y2, plug them into this formula, and see what value we get back. All right, so my 2 points were 0, negative 5. I'm going to call this x1, y1. My other point was 3, 1. I'll call this x2, y2. And if I plug the corresponding information into this formula, the value we get back should be the number that's sitting right here, which is 2. So let's go through that. All right, we're going to have first y2 minus y1. Here's y2, here's y1. If I subtract those, I get 1 minus negative 5. So that is my y2 minus, and then it's a minus 5. I'll do the same thing for the x values. This is x2, this is x1, that's 3 minus 0. If I simplify this number, the value should be 2 over 1, or just 2. 1 minus a minus is going to be 1 plus 5. So that's 1 plus 5. 3 minus 0 is just 3. That's 6 over 3. That is in fact 2 over 1. And the slope is 2. You could use any 2 points off of your equation, run it through this process to figure out the slope. And what this number means is, how is your graph increasing or decreasing, and by how much? So if you start here and the slope is 2, that means you go over 1, up 2, and you end up on the line again. And this always holds true. So over 1, up 2, you could say over 2, up 4, over 3, up 6, and we're always ending up on the line. It might be worth mentioning that, well, if your slope was a negative number, then your graph would be decreasing. If the slope was 0, that means your line is not increasing or decreasing, it would be horizontal, and we'll run into these examples in a little bit. For example 2, I want to work backwards. Here I'm actually giving us a graph of the line, and I want to find the function f of x that goes through those 2 points. This one is negative 4, 4, and this one is 6, negative 1. So all this really means for us is, can I find a slope and a y-intercept, m and b, that match up with the information given over here? So to figure this out, we could definitely cheat a little bit and just count between these 2 points, but I want to try to refer back to the formulas on the previous example. So what I'm going to do is use these 2 points to figure out the slope. Then I'm going to use one of these points to figure out the y-intercept. So I'm going to call this point x1, y1, and this point x2, y2, and figure out the slope m. So just to write that down, this is going to be my x1, y1, and my x2, y2. If I want to know the slope, that's y2 minus y1, which is going to be negative 1 minus 4, all divided by x2 minus x1, which is 6 minus a negative 4. If I simplify this correctly, that value will be the slope. And before we even get a number for it, I'm expecting it to be a negative value since my line is decreasing, but let's see. Okay, negative 1 minus 4 is negative 5. 6, that's going to be 6 plus 4, which is 10. You could leave this as a fraction if you cancel the factors of 5, but a decimal is fine as well. I'll leave this as negative 1/2. The negative means that your graph is moving downward, so it's actually going down 1 and over 2. So by that I mean, if I start with this point, if I go down 1 and over 2, I end up on the line again. Down 1 over 2, down 1 over 2. Also, this is not a very large value, 1/2, that's close to 0. And if you check out this line, it's decreasing, but it's not a very steep line. So the actual size of the value for slope tells you how severe the graph is either increasing or decreasing. Anyway, we have half of this problem completed. I know the slope, I just do not know the y-intercept, so I'm going to take this information and plug it into my formula. That is, f of x is equal to negative 1/2 x, I just don't know b. Like I said, you could look at this graph and say, oh, well, you could just look right at here and say, I think the value of b is going to be equal to 2. But just for sake of argument, I'd like to do this by using one of these points. So let's see. I'm going to use the point negative 4, 4. I'm going to take this information, put it into this equation. The only thing I won't know is b, meaning I can solve for it. Since we have the point negative 4, 4, that's the same thing as saying f of negative 4, you plug in the x value of negative 4, gives you 4 back for the y value. So what I'm going to do is put negative 4 in place of all the x's. I'm evaluating this function at negative 4. As I just said, f of negative 4 means what is the y value at negative 4? I'm just going to replace that whole symbol with 4. This is an equation with one unknown. I'm going to solve for b. Okay, negative times a negative is positive, and 1/2 of 4 is 2. So this equation becomes 4 is equal to 2 plus b. So clearly if I subtract 2 from both sides, the value for b is equal to 2, which does in fact match up with the picture that we have. And this means we have our equation. The function is f of x is equal to negative 1/2 x plus 2. All the values that appear over here should match up with the picture that we have here, and in fact they do. I put one extra thing in example 2, and that's this definition that appears up here. We're going to define a 0 to be any number that when plugged into the function gives you 0 back for the y value. So on this picture, there's exactly one spot where the y value is 0, and that's right here. I'm going to label it. We call this spot right here a 0. It's equivalent to saying it's an x-intercept. So since we have this graph, it looks like that appears at x is equal to 4, but what I'd really like to do is use this formula to figure out the x value, and it should match up with what's on our graph. So to do this, what I'll do is take my equation, I'm going to put 0 in place of f of x, and then solve for x. So I'm going to rewrite this whole thing as, okay, the equation is 0 is equal to negative 1/2 x plus 2. Doing so is saying, what x value makes the y value 0? So this is very easy to solve for x. I'm going to subtract 2 from both sides. This changes the equation to negative 2 is equal to negative 1/2 x. I'm now going to multiply both sides of this equation by a negative, so that will cancel it. And then I can multiply both sides of this equation by 2. 2 times 2 is 4. 2 times 1/2 is just 1, leaving us with just x. Sorry for running out of room here, but I get 4 is equal to x as my final answer. So just a little definition that I wanted to add into this example, but a 0 is any spot where your equation crosses over the x-axis, and if you know the equation, you can actually solve for it by plugging numbers into that expression. And that is it for this example.